Imagine an element that is a bad conductor of electricity and heat, and that has a very generic silvery metal appearance in its solid form. That doesn't sound very interesting at all. Shh, just wait. Now, imagine that same metal having the capability to be the colors of the rainbow when dissolved in solution, an element that had to be kept a secret for years, and all of its isotopes being radioactive. Could this metal really exist? Yes, it is plutonium! At atomic number 94, plutonium is an actinide metal with a serious history. In 1940-ish, plutonium was first identified by Glenn T. Seaborg and his team at California, Berkeley via deuterium bombardment of uranium. Wow! However, this discovery was kept quiet due to the war. But not even 5 years later, the Manhattan Project begun, with the sole purpose being to develop an atomic bomb. And guess who had just the perfect radioactive element for it? Unlike uranium, specifically uranium-235, plutonium-239 has a lower critical mass required to reach the point of criticality. This point ensures that neutrons released by fission will be able to strike another nucleus and continue this chain reaction of nuclei splitting, and thus a mass amount of energy is released almost instantaneously, causing an atomic explosion. Besides being used for war crimes, plutonium alone has some very interesting properties, including the fact that plutonium has a whopping 7 different allotropes. At room temperature, plutonium exists in its alpha phase, with a simple monoclinic lattice structure. As temperature increases, the phase changes from alpha plutonium to beta plutonium with a body-centered monoclinic structure. Next comes gamma, face-centered orthorhombic, delta, face-centered cubic, delta prime, body-centered tetragonal, epsilon, body-centered cubic, and lastly, zeta, but this phase only exists at high temperatures and very specific pressures. As plutonium's crystal structure changes, so do its physical properties. For example, the alpha phase, which has simple monoclinic structure, is brittle, while the delta phase, when stabilized through alloying with other metals, renders it quite malleable. Interestingly, plutonium generally looks like a silver metal when in solid form and not exposed to air, but when it is exposed to air and moisture, plutonium glows with heat due to its pyrophoric nature. When in solution, plutonium can be a variety of colors depending on its oxidation state. Neat. But unfortunately, even with all these cool features plutonium has, it's only really cared about for a more unsavory reason that we touched on earlier. But besides being used for man-made horrors beyond one's comprehension, plutonium can also be used as a heat source in satellites and for other spacecrafts, including the Mars Curiosity rover. It's even been used in some pacemakers in the past. All in all, plutonium is an undeniably intriguing element, from its curious properties to its unique primary application. Thank you.